How you all doing? Unite Austin! Yeah! Are you ready? So you think you can augment reality, huh? Well, by the end of this talk, I hope that you guys are inspired and you have enough information and you can research and figure out how to augment reality. And so you can answer that with a resounding yes! So first, let's do some introductions. I am Jimmy Alamparambil. Try to say that twice. I work at Unity in the Emergent Technologies team. Our team works with partners, and we integrate leading-edge technology that those partners have and integrate into Unity so that developers have access to it as soon as possible. As an example, I worked with a couple of my buddies with the ARKit team, and we created the Unity ARKit plugin. And that was very helpful for a lot of developers to have access to ARKit through Unity. And you can see a lot of apps out there that are using Unity to create ARKit apps. In addition to that, I also created the Unity ARKit Remote that you might have seen yesterday when Sarah and Brad demonstrated it at the keynote. I don't know if you remember that. Basically, iterating in the editor using a remote. My former life, I used to be a game developer in various positions at EA, Ubisoft, Jam City, those kind of, and also smaller developers. Working on some of the games that you see up there. I worked as a game developer, and so when I worked professionally in Unity for a few years before I joined Unity. So I had this sense of what game developers want within Unity, and I keep that in mind whenever I do anything within Unity. When I want to add a feature or create a tool, I think about, okay, what would I have wanted in there to enhance my experience as a developer. So you can contact me at that email address, and I have a Twitter feed at that Twitter feed. And you can look at that. I retweet a lot of ARKit and ARCore apps that I've found interesting, and not even just apps, there's just experiments and interesting things that people have done with those platforms. And I retweet them over there. You can also find me on the forums supporting mostly ARKit plugin and ARCore. And I want to introduce my best AR buddy here, Tim.
Hello.
Take it away.
So I'm Tim. I also work at Unity up in Seattle. I'm on the XR team, and most recently I've been working with ARCore. So I've been working very closely with Google to integrate that into Unity. I've been in games for about a decade. If you're interested in some of this other stuff, you can either email me there or you can find me on LinkedIn. So let's go ahead and get started. So we're going to start out with, thank you. We're going to start out with a high-level introduction to augmented reality, kind of discussing the technology at a high level. And then we're going to talk specifically about ARKit and ARCore as it pertains to Unity and how to use it inside of Unity. And then we'd like to talk about some ideas we have for using both of those together in the same application. And finally, we have some useful demos, some hints and tips for you that we're very excited to show you. And please stay to the end because we have a special treat at the end that I think you're going to be very excited about. So a quick show of hands, who has actually used ARKit or ARCore in Unity? Cool. All right, so it's like maybe about half the folks here, so it's pretty good. So Jimmy, what is AR?
That is a good question. So we always want to start off with that question because as developers and as just users of AR, we usually just tend to think about, oh yeah, we know what AR is because we've experienced it. But as a developer, we kind of have to dig in a bit deeper because we've seen all these videos on YouTube or we've seen videos on Twitter that show, hey, how AR thing works. But we want to dig in a bit deeper to kind of see exactly how the underpinnings and what the workings look like under the hood, so that we can understand how it works, so we can take advantage of those features in the right way, so that we can give a good user experience to our users. So Tim, can you tell us a bit about how these things work?
Certainly, Jimmy. So I'm sure that most of you have heard of something called SLAM. So this is this is a very popular active research topic. It comes out of robotics over the past 20 to 30 years. Stands for simultaneous localization and mapping. Now this is not a specific algorithm, this is kind of an umbrella term describing the problem that we're trying to solve. So there's a bunch of different ways to approach it, but that's basically the problem that we're solving here. So it answers the questions, where are you? That's the localization part. Or the L in SLAM, and also what is around you, so identifying other features or objects around you. That's the mapping part. And if you kind of think about how this might work, if you already know your location, you can kind of work out the position of objects around you. And if you only know the positions of objects around you, you might be able to work out your relationship to those objects. But working them out simultaneously, so when you start up, you don't know anything. So trying to kind of simultaneously solve this system of equations where you're trying to simultaneously identify localization and mapping, that's the S, the simultaneous in SLAM. So there's some clever math tricks to do that that ARKit and ARCore handily provide. So we're also going to be talking about how these SDKs do it, which is something called visual inertial odometry, or VIO.
You have more details on that, Tim?
I'm glad you asked, Jimmy. So if you imagine what a device like this is a Pixel from Android. If you imagine what a device like this has, or how it would perceive the world, it's got a color camera in the front, and then it has an IMU built into it. That's the inertial measurement unit, or it's the thing that measures the acceleration in 3 dimensions, the accelerometer, as well as its orientation in 3 space, so like a gyroscope. So using both of those different sensors in a process called sensor fusion, these SDKs take the camera image, put it through some computer vision algorithms, and what you get out of that are feature points, or point clouds. So this is tracking specific points in different images, trying to work out where they might actually be in the real world. So if you think about it, if you're just kind of looking at one particular snapshot in time, one particular image, it's very difficult to kind of tell very much just from that. But if at another snapshot in time, you've moved the phone slightly, and now you see a slightly different image, this computer vision algorithm can say like, oh, well, this point in this image is the same point that I see in this other image, and I can tell by how much it's moved, and I know how much the phone has moved. So if you imagine sort of like if the point doesn't move very much, maybe it's very close to you. If the point moves a lot, then that means it's probably far away. So you can use that information, or rather these algorithms use that information to sort of figure out how far away these points are. So that kind of gives you a sense of the space that's around the device. Combine that with some math, and out pops the position and the orientation of the device, which we call a pose, as well as other information. You can use those feature points to identify things like surfaces, so planes, for example.
So the current iteration of mobile AR that we're going to be talking about today is ARKit and ARCore.
Sorry.
So what is ARKit? ARKit is the AR framework that Apple produced for iOS. And ARCore is the AR framework that Google created for Android. A bit about ARKit. It was announced, and the beta was released in June this year. We worked, as I said earlier, we worked closely with Apple to integrate that into Unity. And we had Unity support on day 1 via the Unity ARKit plugin. ARKit was actually released to the public with iOS 11 in September. And so you started seeing all these ARKit games appear in the App Store. And actually, if you go right there right now, you can see like a category for AR and a bunch of games there. A majority of those ARKit apps on the App Store are made with Unity. Can you tell us a bit about ARCore?
Certainly. So it was announced and a developer preview released on August 29th. As I mentioned, I worked closely with Google to make sure that Unity had support for that on the same day. And we've already, went too far. We've already seen lots of experimenters using ARKore. So again, we have a very active forum, and we've been kind of watching the internet to see what people make.
So we wanted to talk a bit about Unity support. As you heard yesterday in the keynote, we think that if you have Unity and you're a Unity developer, you're an AR developer. So we have already created the plugins and the support to support both ARKit and ARCore. And we're committed to keep supporting new features of each of these platforms as they get released. So look forward to that. In addition to that, we have provided components and utilities and tools that are going to make your development easier. And we're going to continue to provide more and more of these so that you can basically build on this to create faster, get faster development times and be more iterative. Actually, we are going to talk about some of this later on in the talk as well. So we wanted to kind of show you some of the common functionalities between these two platforms and kind of give you a live demo of some of that stuff. Are you on 7?
Yes. OK. So this is ARKit running on an iPad, but this works exactly the same. Or sorry, not exactly the same, but I'm just trying to go over the high-level features that both ARKit and ARCore provide. So both of them provide support for motion tracking. Again, that's getting the pose information from the device and applying that to the Unity camera. So we've got this sort of floating cube just as a thing that we can walk around. OK. And then I mentioned the feature points. So if I turn those on, this is how the device is effectively perceiving the world. So as I kind of move it around, you get these different feature points. You'll notice, and this is, I think, very important, if I hold it very still, some of those feature points will disappear or just kind of stay static. And it doesn't take much, but if I just move it around a little bit, then it picks up a lot more feature points. So this is kind of important. Remember, going back to how those SLAM algorithms work, if the device is only seeing one camera image from one orientation, then it's very difficult for it to perceive the world. So you need a little bit of motion. You need to kind of look around to really start to pick up features. So this might be something to keep in mind if you're developing an AR app, that you need to provide some hint to the user that either just text that says, hey, look around, or maybe like a spaceship is flying around and the user is sort of interested to, has to kind of follow that around to explore the space. We've also got support for horizontal surface detection. So we're picking up the table as well as a bit of the floor here. We can also do hit testing against those surfaces. So what I'm doing here is just tapping on the screen, and we're putting a cube wherever I've touched. So it's doing basically a ray cast from the point of the camera, hitting the plane, and then we're putting an object there. Of course, you're also seeing the video overlay.
Hi, beautiful people.
So that's taking the texture that comes from the color camera, and we're blitting that onto the screen. But it's actually a little bit more than that. So we also need to copy some of the intrinsic information from the real-world camera, the physical camera, and set that on the Unity camera. So it's things like setting the projection matrix in Unity, setting the field of view, that sort of thing, so that what you have, the sort of AR content that you have in the application really matches, really looks like it's sitting in that surface or sitting at that point in the world. We're going to show this a bit later, but both these SDKs also provide support for light estimation. So that's getting some idea of the amount of ambient light in the scene, which you can then use to shade your objects so that if you turn the lights down, they get dark. If you turn the lights up, they can get light again.
All right. Thanks, Tim, for that lovely demonstration.
Thank you, Jimmy.
So we've talked about some of the features that these two platforms provide, but we also want to talk a bit about the limitations. And the reason we want to talk about the limitations is, as a developer, when we're creating AR apps, we have to watch out for these limitations because you need to work around some of them to provide a good user experience. So some of the limitations are low light. And this is basically kind of obvious because we showed you how feature points work. If there's low light, the image is not good enough to figure out where the feature points are. And so you're not able to detect I mean, basically everything breaks down. The tracking breaks down, as well as plane estimation. When you have excessive motion, the same thing happens. You have blurred images. You can't detect feature points on these blurred images. And so if you move things around too fast, it's not good for the experience. Flat surfaces with no textures. You notice that the table that we're trying this on has a carpet that we put on top so that it would actually show the feature points. Otherwise, we wouldn't, if it's like a really flat surface, like a black or a reflective surface, it's hard for it to pick up feature points. So you have to be cognizant of that. Same with a white wall. You won't be able to pick up any feature points on a white wall. But if it has some kind of texturing or something where you can see some shadowing, then it's easier to pick things up. When you background your app, basically your app loses focus, and therefore it loses the sensors. So it doesn't have camera or IMU. So it loses the ability to track. Same because of what Tim said earlier about how you do the tracking, it's kind of obvious how this works. As far as plane detection is concerned, if you remember that diagram, there's a lot of math involved. You have to first figure out where the feature points are, and then you have to figure out how many of these feature points. You have to have a certain threshold of these feature points that are coplanar, and therefore those and they have to be in that plane that is horizontal, so that it takes a bit of time and a bit of math to figure that out. So you have to kind of be cognizant of that. Now, despite all these limitations, we've seen a lot of amazing apps and experiences. So we wanted to give you a little taste of what we've seen out there.
So where did we get these, Jimmy?
We got it on YouTube.
Yeah, so this is basically a montage of things that we've kind of scoured the internet for, looking for other creations that people have, things that people have done using both ARKit and ARCore.
Where do I put that? Someone moved the video.
Oh, demo fail.
Demo fail. No, that's not it.
What about Spotlight?
What's that?
Spotlight? Like command, just type in unite. Right,
Video's gone. Do you have it?
I've got it.
You don't have the mic. You don't have the audio.
Bear with this live demo fail. We forgot to sacrifice a chicken to the demo gods. All right. You got to switch me over to
8.
Oh my gosh.
The audio.
We lost our audio, but that's okay.
Get the idea. This shows you how accurate ARKit is, or ARCore for that matter. Some cool stuff out there, huh? Cool. So anyhow, right now I'm going to talk about some of the basics of how we can set up a scene in ARKit and basically create an ARKit scene that's easy to use. So just the basics of how we do this in. So ARKit uses the ARKit plugin, and that exposes the ARKit native interface up to C#. In addition to that, the plugin adds components, utilities, and examples on top of that so that you can actually quickly get it up and running with a simple AR app. So let me show that. Let's see. Let's get the basic scene. So this is what the basic ARKit scene looks like. We put a random cube in there so that we can walk around it. Then we have the AR camera manager component, which basically takes it provides the config options to start up an AR session, but it also has a reference to the main camera. And this component takes the AR device's location, position, and orientation, and transfers it to the Unity camera. So it will follow along with whatever you're doing on your device. So the camera itself also has a component, AR video, and this is the video overlay that we were talking about earlier. So it transfers the video from it transfers the video from the camera, so it overlays and has the right dimensions to fit in the world. We also have a generate plane component, and what this does is whenever ARKit generates a plane, it creates a corresponding game object in Unity that will emulate the size and the shape and the orientation of that plane. So as the ARKit plane gets updated and gets bigger or smaller as you detect more and more feature points, the corresponding game object also updates to show that. And you can use our debug plane prefab, which is the ubiquitous blue border that you see, but you could also provide your own 1 meter by 1 meter prefab that basically emulates some plane. We have a point cloud particle component, and what this does is it gets all the feature points from ARKit and creates, for each feature point, it creates a particle in a particle system. And then it displays this particle system, and you have some control over how you can size these particles in relation to the size of the feature point. We've showed some of that earlier, and I'll show it to you again. And then we have this other component, which is basically the ambient, AR ambient, which gets the light estimation from ARKit, and it will alter the intensity of the light that is attached to according to that ambient light estimation that it's getting from ARKit. So I'm going to switch over to the iPad and show you kind of like that basic scene that we had. And where's the cube?
To the right.
To the right. OK, there we are, cube. All right. So basically, when you start off, whatever direction you're facing, that's your origin and orientation. So this is the cube. You're walking around it. Oh, trippy. So, and then you can detect this is the generate planes. I didn't show you the hit cube component, but if you touch the plane and hit the plane, it'll create a gray cube over there. It'll actually just move the cube over there. And then you can see the feature points, the particles. So you get an idea of how simple. This is just basically that simple scene exported into iPad. You want to show us a bit about ARKore?
Absolutely.
The basics?
Thank you, Jimmy. All right, so I'll talk a little bit about ARKore. So again, there's a developer preview. It's a special APK that you download from Google's website. You install that onto a Pixel XL, or a Samsung S8. And then you also grab the Unity plugin from Google, and you drop that into Unity, and you get this. OK, you can see that. So I'll just quickly go through these components. I hope that's not too tiny for you. We've got on the ARKore device game object, there's a session component. So this is probably the most important component. It manages the life cycle of ARKore, the startup and shutdown, as well as some of the configuration options. So the options are stored as a scriptable object in Unity. So you can have multiple of these and pick and choose the ones you want for a particular session. So we've got the enable AR background. So that's the video overlay. You can also enable plane finding and point cloud if you want to have that as well. So going back to this game object, you'll also notice, and this is new in 2017.2, I think it was mentioned yesterday in the keynote, the tracked pose driver. So the idea is that this will drive a game object's pose, that's position and orientation, according to some external device. So in this case, the device color camera, but it could also be, like if it was an HMD, it could be left eye, right eye, center eye. But for the phone, we're going to be driving it using the color camera. Then there's also an environmental light script. So just like Jimmy was talking about with ARKit, this is a script that samples the light estimation information coming from ARKore and applies it to a shader. So we could set the intensity of our directional light, but Google actually found that it looks a lot better if they have a custom shader you can put onto objects, and it's more of like a tone mapping shader, so that it kind of gives it a more realistic look. We're going to show that here in just a second. There's also a point cloud visualizer, just like we have for ARKit, and then also an example controller. So this is really kind of the application logic for this particular example. This just kind of shows how to use everything together. So we've got tracked plane visualization as well as an object that we're going to put down on the plane. OK, so do you want to connect to this so we can broadcast?
Oops.
OK. Cool. OK, cool. So this is that example I was just showing, the Hello AR example. So you can see the point cloud there in the blue dots. And then, we've already got a plane. OK, so what's kind of neat about ARKore is they don't just give you the plane. They actually give you the boundary point. So it's like a convex hull describing this area. Again, hit testing with Andy the Android here. I'm going to try to show what the boundary really looks like. So you can see it kind of growing as I move around. So not just a plane, but an actual convex hull describing this area. I'm going to put down a few more Andys. And I'm going to try to show the light estimation. So I'm going to carefully cover the camera here so that it gets dark. You can kind of see the objects getting darker. So it's actually sampling the image and looking to try to get some kind of general idea for the light estimate in the scene. And do that again. Come on, stage lights. There we go. I think you get the idea. OK, so that's that scene. Let me disconnect.
Excellent.
All right, what do we got next?
So we've talked about ARKore and ARKit separately. And up till now, we actually haven't dwelled on anything new, because this is all existing stuff. And basically, you can use it right now out of the box like this. But a big spoiler now. We have been working on a cross-platform framework that will work across these SDKs. Thank you, thank you. So this was a big request from the developer community, and I can see that you guys appreciate it. Thank you. So we basically worked on a common interface to these two different AR platforms. And the idea is you can write once and deploy anywhere. This is one of the core tenets of Unity. So there is a caveat, though, because we just worked on this for a couple of weeks. So it's still experimental, and expect a lot of changes and possible rework that we might have to do. But it will be available on GitHub, just because we think there is some value here, but we just have to warn that we may have to change some of the APIs, so be careful on relying too much on a standard API on this. But we are going to use this to kind of try and evolve this to more of a production quality cross-platform AR solution. So expect beautiful things in the future. Ooh. So Tim, could you tell us a bit about what this interface looks like?
Certainly, Jimmy. So just we're calling it AR interface for now. So we found that there's so much similarity between ARKit and ARCore that if we just implement a few basic functions on both platforms, then we can have application or game logic just talk to that interface and not have to worry about what platform it's actually running on. So for example, we need to be able to start and stop the service. We need to be able to sample the pose information, position orientation of the device. We need to listen for plane updates, so like added, removed, updated, merged. We need to be able to get the light estimation information coming out of the device, as well as the point cloud or feature points. And then camera handling, so that's setting up the camera so the Unity camera matches the device camera, as well as doing the video overlay. So we have an ARKit interface. We have an ARCore interface. So I'm going to try to show you what that looks like real quick here in the editor. So I'll go to my simple AR scene. Yeah, that's fine. OK, so this is actually just the demo that I showed at the very beginning, which looks a lot like the sort of ARKit demo. So we've got a node, or a component rather, down here called AR controller. So this is what controls the life cycle. This is what connects to the service and then starts updating the camera. And then we've got three options: plane detection, light estimation, and point cloud. So those just ask the SDKs to enable those features. And then you'll also notice that we have a scale parameter down here. I'm going to come back to that a little bit later. I do want to talk about that. And then we've also got some extra just helper components so that we can visualize what's going on. So we've got our plane visualizer and our point cloud visualizer. All right, do we have, is it ready?
That's right.
OK. So can you switch me over to 7? So this is actually just the exact same demo that I started out with, but it's using our interface. So what's kind of nice about this is that this iPad, or rather the code that's running on here, let me switch back to 5. The code that's running on here doesn't have to know what it's targeting, right? So it's talking to the AR interface, which means you can take that code and you can take that exact same sample, and we can run it on the Pixel, we could run it on an S8. So that's really nice. So we started kind of thinking, well, what else could we do? So we went ahead and wrote an editor interface as well. So if I go ahead and hit play in the editor here, this is the game in the lower left. So I've got planes in here. This is the exact same demo. I haven't made any code changes at all. I've got hit testing. I'm placing my cube. I'm going to do that one more time just so I can kind of talk through what's going on. So I've set it up so that it spawns in a plane after a couple seconds, and then another plane after another 2 seconds to kind of simulate, finding a plane. And the reason I did that in this example was that I was kind of experimenting with a game idea where I needed to find 2 different surfaces, and I was going to build a bridge between them. So that's cool. That's actually how we built all of the demos that we're going to show you today. Is actually just we iterated right here in the editor, and then we deployed to device. Didn't have to make a single code change. So that's really useful.
Wait a second, Tim.
Yes, Jimmy.
Are you telling me, that's amazing. Are you telling me that you can actually create an AR app completely within the Unity editor, not have to have any devices around, and then when you finally want to deploy, you can deploy to a device?
Absolutely,
and work.
Jimmy. That's true. But wait, there's more.
What?
So yesterday we saw, not yet. Yesterday we saw the ARKit Remote running on an iPad. Today I want to show you the same, OK, go ahead. Today I want to show you the same thing running on a Pixel phone. So this is remoting working on a Pixel. So what we did is we wrote a remote interface, which means the application, again, it doesn't even know it's talking to a remote. It thinks it's just talking to the AR interface. So this is actually the same app, just with a few extra remote controls on here. And if I can find a plane to hit test against. Well, we're not finding a plane right now.
Go ahead. Can I try and find that?
I think it maybe lost something. Huh. OK, well, another chicken we need to sacrifice to the demo gods. This is the most experimental feature that we're showing you today. But our plan is to have remoting working across both devices, so that, and you can, again, you can just test right in the editor, or you can deploy, you can hit play in the editor and use your device as a remote control. So it's sending pose information. You see the feature points. It's sending planes. So that's really cool. All right.
Cool. Awesome. All right. Now we want to talk about scale. So one of the most requested features that developers have, other than the remote, has been scale. So essentially what they want to do is create an experience that doesn't have to change what they authored. So they might have authored at a different scale, and they want to fit something into the tabletop or whatever they want, whatever surface that they found. Now, I actually wanted to do something like this as well. I want to be part of this scaled content club.
Are you saying you want to join the scaled content?
I do want to join the scaled content club.
Well, I'm afraid there's a couple of rules.
What's the first rule?
First rule is don't scale your content.
Oh, OK.
Do you want to hear the second rule?
There's a second rule?
There's a second rule. Do not scale your content.
Oh.
So why not? So the first thing that you're probably going to want to do is just simply take all of your assets and scale them down. So an example is maybe I'm making a tower defense game. My towers are authored at, say, like 4 meters tall or something, which is great if you're making a traditional video game, because you can pull out and get a bird's eye view. You can swoop in and kind of get close to the action. You want to get all of that detail. But it becomes a little bit more complicated if you want your towers to, say, just be, you're going to fit them on a tabletop, so they're going to be just 5 centimeters tall. You could try to just scale the content down, but there's a few reasons that you don't want to do that. So number one, if you're using assets from the asset store or something, they're probably not authored at that scale, so you're going to have to do some extra work to shrink them down. Also, if, say that you have physics on it, you want very realistic physical interactions, your physics behavior is going to change. And probably kind of one of the worst possible use cases for a physics engine is to have a lot of very small things that you're trying to stack up. So if I was trying to make, say, a Jenga game or some kind of block stacking game, to do it actually at centimeter scale where the blocks are really long and thin and very, very tiny, you're probably going to run into some things like jitter problems or instabilities. So it's better to actually keep it at sort of meter scale and instead do one of these things that we're going to talk about. Also, one of the other problems is that some content actually just can't be moved. So for example, if you have a really complex level, you don't want to be like moving that around in the world. And then some systems within Unity can't really be changed after they've been baked down. So for example, if you have a nav mesh or terrain, those kinds of things can't really be scaled or moved or rotated after they've been baked.
Light mapping.
Light maps are also going to be a problem. The particle systems do have scale, but there's not really an overriding scale factor. So if you have an existing particle system and you want to scale it down, you've got to go in and kind of tweak each parameter. So we've got a couple of options. Option one is the simplest thing you could do is simply just scale the camera. And what I mean by that is scaling really all the positional information that's coming out of the device. So one way to think about it is that these devices kind of have their own sense of own space, right? So they start at 0, 0, 0. And they operate in meters. And what you really want to do is transform that device space into sort of Unity content space. So you're just basically translating between two different coordinate systems. So if we scale the position of the camera, leave the orientation alone, that's fine, and then also scale the position of the planes as well as their extents, and we should be fine. We're going to show you an example of that. But first, there's also another option. Jimmy, maybe you can tell us about that.
Yeah, thank you. Option 2 is using multiple cameras. So similar to option 1 in a way, but essentially what we do is we take the AR device camera and actually don't translate or rotate it at all. We just keep that as is so that all the information, like the points, clouds, and the planes, all remain in the space of the AR device. Now, what we do is create another camera or 2 more cameras, but the second camera will be for the content. So if we basically take the second camera and then offset it. So we create a parent transform on that scaled camera, scaled content camera, and we offset it and rotate it based on where you want the scaled content to appear and how much scale you want it to be scaled. So let's say you have a certain size object that you want to fit into this space. What you do is move the camera back all that way and render the content from that camera that's far away. And this camera will also move with the ARKit device in the same way, but it's parented to, it has a parent that actually translates it in a different device space, a coordinate space rather. So you want to show us what option 1 looks like?
Yeah.
Oh.
Let's do it on here first.
Right.
Okay, let's go to our scaled content example. Okay, so I'm going to start with a castle. This is just a really simple castle asset. But let's say that this was like a complex level geometry, and for whatever reason, I don't want to scale it or move it or even rotate it, after I've brought it into Unity. Now, the pivot is at a pretty decent point. It's kind of in the middle of the castle towards the base, so that's a good place to use as like an anchoring point. But notice that its position is actually not 0, 0, 0. It's, for whatever reason, it was just authored that way, and it has a non-trivial orientation as well. So what I'm going to do is, if you'll notice the way that we've set up our AR rig. So again, this is the same components that we had before, an AR controller, as well as a plane visualizer and some other demo stuff that I'm going to show. But this is all one game object, and then the camera and all subsequent device information is going to appear below that node. So where we're going to apply the scale is actually on this root node. So if I go ahead and hit play in the editor here, you'll notice that for the scale value, I've put in 10. And that scale gets applied to this AR root object. So 10, 10, 10 there. That has the effect of scaling the camera's position by 10. It also is going to scale the planes that we bring in. So the planes get affected by the scale. That means that their position and their extents are also equally scaled. Now, if we look again down here in the game view, what I want to do is effectively place this castle on the plane, right? But remember, I can't actually move it. So if you notice, if you take a look at, keep your eyes on the scene view up here. Oops, if I can use a Mac. So when I place it on the plane, what we're actually doing is moving the rest of the scene around it, specifically that AR node. So we're moving the camera and the planes. We're not actually moving the castle. And with a little bit of math, we can actually make that look pretty good. So I can make the castle go down, make the castle go up. I can rotate the castle. But in the game view, it looks like I'm rotating the castle, but I'm actually just orbiting the entire rig around the castle. So it's pretty obvious what's going on here in the editor, I think. Let's look at what it looks like on the actual device. OK, so I've got my planes here. So I'm putting the castle. Remember, I'm not actually moving the castle. I'm moving everything else. I can scale it up. Let's rotate it around. And of course, we've got physical. Oops, I tapped on the plane. We've got physical interactions as well. Now, however these physical interactions look is fine at this scale, but let's say that I want to change the scale. Well, I can do that completely dynamically because remember, I'm not actually scaling the physics world at all. I'm just pulling the camera back. OK.
Cool. Thank you.
I think I hit the wrong button.
Thank you. So another big request has been getting a shared multiplayer experience in AR. Now this has been a hard problem, but Unity has a lot of solutions that help along with this problem. So first of all, we have, if you looked at, if you know about the tanks demo, this is one of the tutorial assets that we have in the store, in the asset store, that anyone can download and play around with for free. There is also a less well-known tanks demo, which is the tanks networking demo, that is also on the asset store. And that allows you to connect between multiple users on multiple, whatever cross-platform devices that you have. You can connect from PC to iOS to Android to other Mac, whatever you wanted. So that demo exists on the asset store. And so we started off with that demo. And what we did was we removed the camera rig, because what we want to do is, instead of using the gameplay aspects of it to test the camera, what we want to do is we want to take the AR device and attach a camera to that so that it can move around and see what's happening from an AR point of view. The other thing we did was add a flow. So the flow of the networking demo is actually start with a lobby, select your players, and then go to the actual game, and then come back to the lobby. So instead of that, we add a scene right at the beginning to set up our AR scene. So we set up the AR scene and set up all the things that we need before for AR, and then we go to the lobby, and then we connect and go back. So the first thing that the AR setup scene does is when you basically sync the scene location between the two devices that you're using. And the other thing it does is it creates a camera with the right scale and offset so that the world, or of the tank's world essentially, which is actually 110 meters wide, will fit onto that table using some of the techniques that Tim talked about earlier. In fact, using the same technique that he talked about earlier. So there is also something new in it, which is how to fit to a scale of the table automatically, correct?
That's right, Jimmy. So what you saw me doing earlier was just affecting the scale with a simple slider. But let's say that you know exactly how big you want a piece of content to be. So how do you fit it, for example, onto this table? So in this example that we're about to show you, we know that the level geometry is 110 meters wide. But we don't know how big the plane is going to be, before we find it. Before we find it. So we can't just simply set, a value in our UI. We need to actually do it dynamically. So it's very simple. We simply take the level geometry, or the size of the level geometry. So it's square, and so one edge is 110 meters. And we divide that by the size of the plane. So say, for example, if this table is half a meter wide, then it's 110 divided by a half. So 220 meters. Or that becomes our scale value, 220. And that has the effect of shrinking the level down by a factor of 220 to make it exactly half a meter wide. OK, so we're going to try to show this.
Live?
Trying to do it live.
Are you crazy?
I might just be.
Yeah.
OK, I got
this.
I'll do ARKore, you do ARKit. All right. So we're both connected. Good.
Are we both on? All right. Oh, demo gods.
Can you get rid of that thing that says live? You know what that's about?
No, it's gone.
No,
On the what?
it's like recording or something. What is this?
No, it's not. Is it?
OK, well, we'll just roll. Oh, there it goes. OK. Great.
All right, ready?
Already.
All right, I'm going to detect a plane
OK, I got
on
mine.
this table. OK, you got
The whole
yours?
thing.
Going to get the whole thing?
Yeah. OK,
All
we're
right.
good.
Going? OK, you're going to create a game?
Yeah.
List the servers, no servers?
Oh, I click connect. There we go. Do it again.
There we go.
Yay.
All right.
Ready?
I'm going to join your game. Oh, there we go.
So I'm on a Pixel, and Jimmy is on an iPad. There we go.
The
I'm
controls
coming for you.
are not very good, but I made these controls in a couple of days.
Gotta get you. Oh, I'm sideways.
Woo! Come on!
You can't get me.
Yeah! All right. That's a lot of fun. That's a lot of fun. How do I get rid of this? There we go. All right, that's it. It's a wrap-up, a summary. ARKit and ARCore already provide you with a ready-made audience for AR. And you can basically take advantage of this. You can tap into the potential because it's a huge market there for you. You can use Unity as your authoring tool, and you can code once and deploy anywhere. We provide tools to quickly iterate on your AR content right in the Unity editor. You can just use the editor to actually create all your content and then deploy later whenever you have a device. We provide higher level components, examples, utilities, and we'll continue to do so. And we'll continue to provide what you guys request.
So, these things, they both came out this year, just a few months ago. And, we've kind of seen AR before in some other devices. But I think this is really kind of, we're hitting this inflection point where now, everybody's got a smartphone in their pocket these days. So it's a really exciting time for AR. You can really reach a lot of people this way. And what we kind of showed was an existing game that we then put into AR, and that's pretty cool. But I want to see something that's really unique to AR and that you can only do in AR. And now is the time to start figuring that stuff out. So now is the time. Somebody in this room is going to be the next innovator in AR, I think. So we also want your feedback. It's part of our job is to make your guys' lives easier. To make developer tools, to make iteration time faster, so things like where the editor interface or remoting that Jimmy has done. But what else can we do? So we need your feedback. We have there's forums for both ARKit and ARCore, so you can check those out. And then right after this talk, so probably in about 20 minutes, we're going to be downstairs in the main expo hall. There's a section called Ask the Experts, so it's right in the middle of the room. You just walk straight towards it. We're going to be at a table down there at 3 o'clock. And then please tag us in your creations, or at least Jimmy. Jimmy's the one with the Twitter account. So if you make something really cool in ARCore or ARKit and you want to show it off, please let Jimmy know.
All right, thank you, folks. We have some time. Thank you. We have 5 minutes for some questions. Please come up to the mics so that people can hear your questions.
Hi, so I'm working on a marker-based solution, so I'm using Vuforia, and I'm encountering the scale issues with particle systems. So will any of the tricks you showed work with Vuforia, with the scaling of the camera?
Yeah, that's a good question. So I don't work directly on Vuforia, and I can't remember if they take over the camera completely or not.
So as far as the scaling is concerned, again, as long as you don't scale the particle system, you can use the same trick, right? Basically, you scale the camera away from the particles. So the problem is, though, if you have a particle system that is too small to see when you scale out, you have to make that particle be like the size that you need to be able to be visible.
In my case, I'm just shrinking it down, and then it's obviously you have to scale you have to change the individual parameters.
Yeah, you don't need to do that. All you need to do is you have your particle system in the right, in whatever coordinate system you have, and you keep it in that, and then you just move your camera back enough so that it looks smaller, that it fits within that. And the code is going to be available, so you can have a look at how it works.
Right. So that's my second question. So the demos and the AR Tanks demo, they're on the asset store or downloadable, or?
The AR Tank, so the stuff that we showed today is not available right now. It'll be available in 2 weeks or so. It'll be available as an open source project on GitHub. It's still evolving, so obviously you're going to expect some issues and stuff. So we're trying to get community feedback and maybe help with improving it essentially. So, but the plain AR tanks, the plain tanks demo and the plain networking tanks demo already exists on the asset store. So that's the answer to your question.
Great, thanks.
Hi, Valentin. I'm an XR developer, designer with Accenture. I've been doing AR for the past 6 years, so I guess I'm a hardcore veteran in the field,
Right on.
Especially for phones. And so I've used Vuforia plenty. So my question is, and the HoloLens as well, is there a way to persist sessions, like meaning like any sort of point cloud or mesh syncing, so when you leave the session, the object will still anchor in the same place?
Currently, no. It's not something that the SDKs, either ARCore or ARKit, give to us, essentially, out of the box. But possibly in the future, and possibly, I mean, there's something that we can do at like a C# level or at a plugin level to kind of save off some of that stuff. But it's not something that's possible right now.
Got it. And what are the main advantages over using Vuforia or like any of the previous like SLAM algorithms like Meta.io, Layar, and any of the other ones that used to be in business or not in business over ARKit and ARCore?
So the ARKit, again, like we talked about in the beginning, the main advantage of using ARKit and ARCore is that they have the sense of fusion. Essentially, they are able to create a pretty good impression of the world by using these feature points, but it needs a very careful calibration of the camera image and the algorithms used, the computer vision algorithms used to detect these feature points, as well as a fusion with the IMUs that are in these devices. So if you notice, the ARKit is only works on an A9 GPU or APU or better, and that's because it has those computational limits, right? It has to do a lot of computation. So, but also the tight integration between the camera and the IMU helps that to become way more stable. Like, so for example, if you look at that cube, and then create the cube in AR and that scene, and then move around, go around the hall, and come back, it'll be exactly in the same spot. That's not something that was possible on previous iterations of this, of mobile iterations. So that's the advantage.
So second last question
Yeah.
is
Second.
networking is awesome. Like, that was really cool, really impressive.
Thank you.
Are you planning on releasing that for LAN as well?
Yeah, so that demo, you should just take a look at the asset store demo. It actually has, you can do whatever you want. You can basically connect in a different way. So this is just built-in multiplayer on Unity. So it's an existing thing that already it's an existing way of connecting between arbitrary devices. So it has, if you looked at the screen, you can show them the screen again. If you looked at the iPad screen, maybe.
Oh.
If you look at the screen, they had like, on the connect screen, they had like create, so it would create a matchmaking session. But below that, they had like a create, just a host and, like a direct like LAN player. So you can do all these things.
Thank you.
Thanks.
Hi, I'm Faisal Sharif. I'm actually an engineer with Oracle, and I did want to congratulate you guys on the networking between ARKit and ARCore.
Thank you.
Thought that was amazing.
Thank you.
My question is involving machine learning capabilities and potentially some object recognition. Like, have you all thought about incorporating machine learning agents with, like, can I actually grab that camera data and feed it to an agent for like object recognition?
No comment.
Sorry, you want to grab the pose information or the camera, the raw camera texture?
Camera info, but also some of the pose information too, like the point cloud information.
Oh yeah, you can just, you have complete, you can just raw access to that, yeah. Just like as an array of vector 3s or something, yeah.
All right, cool.
And same for the pose.
So if you're interested in iOS, so ARKit, iOS 11 also has it has some frameworks that are
Yeah,
included,
Core ML.
like Core ML, as well as Vision, which is also able to do some of that object detection and that kind of stuff. So there's some stuff there that could be interesting to look at.
All right, thank you.
Thanks.
Hi, Suleiman here. I work for CareerBits, and we've been creating a social augmented reality app. And the thing we realized so far is how dramatically the battery drains fast when we're using the AR feature. So I just wanted to ask, are you working on something right now to reduce the battery consumption on using those AR features?
So I think that's kind of, I don't want to say it's not up to us at all, but it's more of a function of the SDK that we're using. So we're just kind of turning on ARKit and ARCore and then just listening for, listening for information or asking for information from them.
But there are things that we can do at the game developer level. For example, one of the things you could do is after you detect your plane surface, you can reset ARKit or restart ARKit without resetting the tracking. So in other words, you'd still be in the world, but you just reset it with a config option that says don't detect planes anymore. So you've already detected your planes. So I believe these SDKs are going to start coming up with less, ways to get less and less, create modular, granular ways of, okay, I don't want this option, I don't want this option. So then it'll become less expensive to cover.
Gotcha, thank you.
All right.
Hello. Quick question actually about skyboxes. Or
Skybox.
specifically reflection probes. Something we've been trying to do is basically have interactions in arbitrary points in GPS locations. And we've kind of been able to gain this by knowing those exact GPS positions and then sort of taking photos there and making a skybox ourselves. But do you have any ideas for how to dynamically create a skybox based off what ARKit is seeing at the moment? That seems like
That's a good question.
Not really, but we can talk about it at the Ask the Experts.
Okay.
Come and see me there. You might want to talk.
Hey, thanks. Really amazing demo. So I have.
Thank you.
I'm actually from the architecture design background, so I'm interested about those networking or sharing the experience. I'm wondering, is that possible if it's purely only depends on the internet? Is that possible to do remotely? For example, I have a table here, and also my friend have a table in Europe, in
Yes.
China or somewhere.
It's possible. So
And then
actually,
how-
the way
how is that set up? Is it the same setup?
it's
or?
the same setup because actually currently the way we are syncing the locations is just detecting the plane and saying, okay, this is the plane I want to place my experience on. So he could be in Tokyo and he could say on his table, I want to place the experience on here. But we could also do syncing where we are in the same space
Right.
and sync the actual points together and say, okay, this is where we want to have our experience.
Okay.
So,
I
but we
guess
can
that
do
would
either
be-
way.
And I
it's-
guess that would be slightly difficult because you probably need some avatar to represent your friend where they're. Is that possible? Or
Yeah, because what you can do is you already know the camera pose of, so you can have like a device being moved around in the world according to what your friends looks like, right?
Awesome. Thanks.
Thank you. Thanks everyone. Come
Thank
back
you,
to the
yeah.
Ask the Experts. Come on.